Okay, hello everyone, and welcome to the first meeting of a group of people who are interested in the MicroJIT contribution that was opened by Scott Young as PR 9578. So the goal of these meetings is to make sure that the OpenJ9 community understands some of the details of that pull request and what that group is looking to contribute to OpenJ9, and also to discuss how this MicroJIT will fit in with the rest of the compiler infrastructure in OpenJ9 and or OMR, depending on if it's Java specific or not. We may want to consider whether they want to contribute any parts of it to OMR. But if we're focusing on the OpenJ9 part, we certainly want to understand how it's going to fit with the control logic and the existing control infrastructure inside the existing JIT. As well as I myself am particularly interested in which parts of the code can be shared with that implementation and which parts need to be duplicated, especially around the CodeGen backend, since I would hate to have to duplicate all of the binary encoding and everything for all the platforms, because that would be quite a lot of work. So the first item that I put on the agenda is sort of the frequency of meetings and the agenda structure. I did create a box note. The intention for the box note was so that people could add items to the agenda. I found out that apparently Box is not always allowing people to edit the document publicly, even though that's the setting that I provided on the document. So I'll discuss with Dan Hidenga from OpenJ9 about how we can, how I can get a Google document set up more like what we use for the regular community calls, so that we can have the agenda editable, so anyone can add items to it. I'm not sure how frequently we want to have these meetings. I think we're going to need a couple to at least get through the design and start getting through the review. But before we plow into anything in particular, are there any other points that people are wanting to see addressed through this process, or suggestions on how we should run things to keep this nice and efficient for people as we try to address the questions? No. I'm going to assume stunned silence implies people kind of agree with that. My default assumption was we probably would start with a frequency of maybe every 2 weeks, just so that there's time between for people to look at things. But I was hoping that we might actually start off our discussions with Scott providing a little bit of an overview of the design of the MicroJIT as currently being contributed, and what you see as the integration points into OpenJ9, and then maybe we can develop a bit more of an agenda from there as to particular areas we need to explore. So Scott, could you maybe just give us an overview?
Not a problem. So basically, the way we've designed MicroJIT right now, it has relatively minor number of integration points, I'll say, with TR. The intent is to have MicroJIT integrate a little more heavily, either to reduce code reuse or provide features to TR, such as omitting profiling instructions in code generated by MicroJIT, so that TR still gets a full profiling data set. However, right now, the main integration points are in the compilation thread file, the compilation info per thread base class. There's a function wrapped compile. And this is, to my understanding, because I don't have a strong understanding of what wrapped compile is supposed to do, it's essentially just a way to call the compile method of that same class with essentially some thread safety wrapped around it, so that that can be done asynchronously. So we hook in there, and right before the compile to, or the call to compile, that would start IL generation and code generation. we insert another call if it's supposed to be a MicroJIT method, and we call the MicroJIT compiler instead. The other integration point is related to the interpreter and how we determine how something should be compiled and ran. So J9 methods, we added an additional extra field. So the extra field usually holds the count and then holds a pointer to the compiled method. Since we don't want to override TR, neither its count nor its compiled methods, MicroJIT needs an equivalent extra field, so we created an extra 2 field. So we use that extra 2 field to kind of signal whether something is being compiled for MicroJIT or for TR. So if TR shouldn't be compiling it, but MicroJIT should be compiling it, then we call the MicroJIT method. In there, we start our code generation phase. So the way that works right now is very similar to compilation info per thread based compile. We get our port access. We set up all the things for asynchronous checks and for ensuring that we keep track of the number of compilations. We get access to some metadata things like the bytecode iterator, and we get the method details. We get access to the ROM method, and then from there we enter the microjitting of the method. So we go to the MicroJIT code generator. So the MicroJIT code generator is a templated code generator, and so the way it works is we first generate the prologue and our pre-prologue and prologue, and the way we generated those is we looked at what TR was outputting for some simple methods, and we more or less copied that in pieces in assembly. And we programmatically copy the assembly code that's required for what we're doing and fill it out. And that includes painting registers, all that fun stuff. The body generation takes in the bytecode iterator, and we look at every bytecode one at a time, and we have a separate assembly file filled with templates. And that assembly file will have, I'll just pull up an example template quickly to read one out. So for example, for loading, we have an architecture that's kind of like the virtual machine architecture for MicroJIT, and we'll use the R10 register as kind of like a Java stack. And the load template will is broken up into 2 templates, one that makes space on the stack by subtracting a slot size from R10, and then moves a value from the local array, which is pointed to by R14, into R15, and then we need to patch that, so that's a separate template. And then the second template just moves the value from R15 into the top of the stack. So we're using R10 like a stack pointer, and then we use a number of other registers as either pointers into arrays or just a place to hold a value while it's being moved from one memory location into another. Kind of like how Andrew suggested he didn't want to copy all the binary encodings. When we were first designing MicroJIT, we didn't know how all the binary encodings were implemented in TR, and the previous MicroJIT had been using essentially assembly templates. So we took the same kind of approach. We made assembly templates of everything we wanted. If an individual bytecode needed more than one template, it was broken up into parts. And the breaking point for every template is essentially a patch location. So if a single bytecode needs more than one template, it's usually because we need to patch more than one value. And the last instruction in every template that requires patching is the patched the instruction that requires patching. So inside the code generator for MicroJIT, every time we need to patch something, it looks like a macro call to copy the template into our code buffer, update the size information we're using, and then patch that buffer location with a call to a patch instruction or a patch function that will patch the instruction by automatically doing all the math to get to the right location and patch it with the right value. It requires right now at this point a little bit of assembly knowledge, or rather binary encoding knowledge, or some testing with NASM and the correct arguments, because you need to know before you patch how big the patch area is, how much data you, like what the size of the data you need to patch is. And we, up to this point, have been using our own linkage in terms of the linkage class. However, we haven't had much use of the linkage class so far, so we could probably reuse TR's linkage class. But at the same time, a lot of the things that we're doing that the linkage provides for programmatic usage, we haven't been doing programmatically. We've been doing manually. Things like which registers are used for what purposes. MicroJIT currently, as I alluded to before, uses a Java stack. So it doesn't do register assignments or register mapping, doesn't check lifetimes. It doesn't do anything like that, and tries to be, I'll say, as sparing as possible with its memory usage on the JVM side. So we try not to use many metadata structures. If we can get something later for a few more CPU cycles, that's probably worth it a little bit. If there's metadata we need to hold, we haven't been using the IL or anything in that area. We haven't generated any IL. We have a 2-pass compiler right now. So the first pass, we gather any metadata that's something that that needs to be known ahead of time. Things like the types of slots, so that we can get the correct category information when we get to bytecodes that have category dependencies. And for knowing how much data we're going to need to make space for things like calling static, or we don't have invoke virtual yet in our private repository where we've been kind of working on this before making PRs. But we did get invoke static working, and we need to implement in our first metadata pass how much space needs to be saved on the stack so that we can call that ahead of time, reserve all the space ahead of time. But most metadata that we use is stored in tables. So for things like the GC for stack maps and the stack atlas, all the information we needed for that was stored in tables. For making things like where we would store local variables, our local table, knowing how much space we needed and which things would be in what location, we made tables that we parse through. We parse through in the first metadata pass to figure out how many local variables there are and what their sizes are, what their data types are, all those things ahead of time, and store that in a table. So rather than store things in IL nodes, we've been making basically just arrays for our metadata.
Okay. I guess just as a side question then, just before you talk about anything else, then are the stack atlas and stack map and everything also existing with their own implementation? Like there's no shared code at the moment with any other parts of TR or like the core compiler component or the interpreter or GC? Like you guys have just duplicated that and done your own thing?
So we use TR GC stack atlas.
Okay.
and our maps, our parameter map, local maps, we haven't gotten really into anything with the new operator or things that return objects yet. So we haven't really exercised these too much yet. And I'm not yet clear on how to signify when a map is no longer valid, or how that map structure works yet. But right now we have kind of the for static and for getting and putting fields when you don't change really the shape of what is where on the in registers and on the stack, so that everything's kind of static from GC perspective when you first call the method. We've got the parameter map and the local map, and we create TR GC stack maps. We just have to create them differently because we don't have the IL structure. So we have a create stack atlas in a MicroJIT cogen GC that does the code generation and metadata stuff for GC related things.
Right, I see. Okay, thanks for that.
Welcome. Another hooking in point for integration that just reminded me of, the metadata file where things like the stack atlas are called and created. We had to create some extra methods or functions there for creating metadata that was specific to MicroJIT, because a lot of how those methods work is going through the IL, and we don't have the IL. So in those cases where things for MicroJIT, they were created from the TR methods, like from a copy of the TR methods, but then they were modified to get their data from other locations. So one way we could, I guess, reuse those things would be to somehow provide as arguments the means to acquire data for creating metadata. But that kind of that would require like changes to TR and changes to MicroJIT, and gets a little hairy. So I don't know that that's necessarily a great option. For some of these things, we might need to have a duplication, I guess.
Yes. So if it sounded like I am against duplication entirely, the answer to that is definitely no. There are certainly my personal belief, and others on this in this group may wish to express a different opinion in a moment, but there's certainly some things where duplication may make sense. But I think it's because we're looking at a contribution to the OpenJ9 project, the community is going to need to be able to maintain or be able to be responsible for maintaining the implementation that's contributed. And so I think we need to be a little strategic about where that duplication takes place, just to minimize the amount of double maintenance that has to happen, because I would hate for this great work that's being done to diverge too much or too quickly from the main velocity of what's happening in the project, because then it will lose some of the value that you guys you're looking to contribute, which we greatly appreciate. So this discussion is not meant to be, oh, you mustn't duplicate anything. It's more to make sure that we all understand the choices that are being made, and to assist where deduplication, so that there's a unified implementation makes sense. So hopefully that makes it a little bit more clear, kind of what the overall intent is, anyway.
So I didn't harbor fears of that. I that wasn't what you were saying, but thank you for saying that anyway. That probably may have put some hearts and minds at ease here on the USB side, that we won't have to do any restructurings of this, specifically to eliminate all code duplication. But more what I was trying to do there was identify possible places for code duplication elimination.
Yes, and I very appreciative of you guys being open to that idea and actively looking for it, because I think that if we collaborate on that, we'll arrive at the best design overall for the project as a whole.
Agreed.
So I guess did you have anything else you wanted to add, or is that sort of the end of your overview there?
So I guess that's the end of the overview, unless people want to get into the specifics of what registers we're using for what.
Yeah.
I don't.
I think, yeah, I think before we drill down to that level, I would like to pause, and there's a number of other committers and significant contributors on this call. So I would just like to pause and allow them to ask any questions or express any views that they would like to make known at this point in the discussion before we proceed any further. So I'll just pause for a moment and allow anyone else to make comment if they wish to.
I'll start with a question about the modifications that you made to the J9 methods. You added an extra field there, an extra field. Is that because you're going to have different counts for the different invocation counts for the microjitted methods than you would with the regular JIT, full JIT methods?
So originally, we were not intending to have a different count. We were going to store a threshold in extra2. That was what the previous work that did something like this in J9 did before. However, that caused some problems with the static and special glue code for x86-64. So we did actually have to create a separate invocation count and use that, put that in the extra2 field. But the main reason for needing an extra2 field was so that we could continue counting with TR even after having compiled a method with MicroJIT, because we need the field to store the pointer to the compiled code anyway.
Okay. Just think about that for a bit.
Yeah, that kind of goes to where the question I was going to ask is the intended use of this. Is it thought to be as a early tier to get out of the interpreter faster and into JITted code, or is it intended as a standalone replacement for TR in constrained environments, or is there some other, or all of the above and other things as well?
I would say all of the above. I don't know about other things as well. So the intent was that in a resource-constrained environment, you could use MicroJIT by itself. And we've been mulling over internally how we could maybe set up defines for compiling so that you could specify that you want to compile with only MicroJIT, and then have the required pieces of TR that MicroJIT leans on with the pieces of TR that won't get invoked, and then remove all the fields that are added to support MicroJIT when it is running in conjunction with TR. And then also change any field which uses extra2 to use extra if you're just using MicroJIT and not using TR. But that's how we implement that, is something we've been thinking over internally. But yes, the idea is that in a resource-constrained environment, you would just use MicroJIT. But also in a server environment, when you don't have access to things like JIT, shared class caches across multiple instances, or if you're not currently set up with JIT server or any of those other alternatives, that essentially you could use MicroJIT as kind of like a replacement for the current quick start. So the idea was that if we omit profiling instructions and our code is faster than interpreting by a significant amount, then you could get to TR with the same quality of profile data faster. And then from there, you would be able to compile with TR as if MicroJIT had never been there.
It sounds like certainly a great story and avenue to investigate, and it sounds then like you're open to redesigning that connection into the J9 method to integrate more closely into TR when you're running in that combined environment. So,
Yeah.
you know, investigating things like using the sampling threads to drive recompilation out of the MicroJIT and into And into TRs compiles rather than adding extra count fields into methods.
So I'm not familiar with those areas, but if that's a thing that can be done, if we can somehow get to the same triggering point without actually modifying count and compile, and kind of hide from the interpreter that there is 2 JITs when there is, that would be very interesting. That would possibly also solve some of the problems that have popped up related to invoke static implementations right now. I'm currently working on a bug with invoke static where it seems that having 2 fields that are both being counted is sometimes causing a method to not enter compilation from MicroJIT. So that's a bug that I'm currently working on internally, trying to finish invoke static. And if there's a nice, clean way to kind of distance ourselves from this counting mechanism, that would be very nice.
Yeah. So the way things work today is we keep a single count in the methods, and we try not to grow the methods because there's a large number of them in the system typically. And so every field that we add is a fairly large footprint cost. So the way these compiles get driven today is there's the count to drive the initial compile, and then the sampling thread that periodically walks the stack and figures out how much time is being spent in any given method to determine when to recompile it. So ideally, we would have MicroJIT fit into that kind of mechanism. So the sampling thread would drive the recompilation out of the MicroJIT code and into the full TR.
I'd also be interested to hear if Marius has any particular thoughts, since Marius is a significant contributor into the control logic, especially on the JIT side of things.
Yeah, so sampling is not going to be enough to recover the entire performance. We already know that because we've tried downgrading everything at all, and we have to rely on mechanisms like GCRs for counting mechanisms has to be in place in order to compile a significant number of methods to, again, recover. I was also thinking that with the 2 extra fields, maybe it's possible to keep just 1, and then when that count reaches 0, you take a decision. I want to JIT compile or MicroJIT compile, and if it's MicroJIT, then we can replenish that count with some value and keep it decremented. Though the MicroJIT has to do the decrementation now, so the MicroJIT code would have to keep decrementing this extra field that has now a new value, and when it reaches 0, it must somehow trigger a recompilation for the full JIT. I'm not sure if it's entirely possible, but an idea.
Marius, just to make sure I followed that. The idea is that the MicroJIT would continue to do the counting in its compiled code,
Yes.
keeping that count in its own data state to drive the recomp, not in the J9 method.
Yes.
Okay.
Or it could be even the J9 method if you are willing to change that extra, which now extra has reached. Oh no, because extra now only hold the pointer for the MicroJIT, so you can reuse it. Yeah.
Yeah,
it
would probably look more like the GCR compiles that the JIT currently does, right? So it would be a self-counting body.
Right. Yeah.
Yeah. So I guess just to focus our discussion a little bit, so there is a pull request that's open, and as a project, obviously, if this is technology that we're interested in, then we're going to have to the review of this PR is going to need to be completed, and we're going to have to decide what, if any, changes are going to be needed to it before we can accept this initial early prototype implementation. It sounds like there's going to need to be some kind of change related to the like the control integration, just whether it is a more GCR-like thing or whatever, but just to make sure that it integrates smoothly and that we don't have excessive footprint growth in the J9 method. At least that's the sound of the discussion. I guess what is I guess one of the other questions that I had was that while this is being done for x86 and you've manually been generating assembly sequences and things, what are your thoughts, Scott, about how we're going to support the other platforms that OpenJ9 supports? Right, there's Power, Z system, like the Z architecture, ARM64, and a growing RISC-V implementation. So we don't really want to leave those behind in terms of functionality. So have you given any thought to how we can lower the overhead of getting those guys able to support this technology?
A little bit, yes. So we've done some we've done some structuring in terms of how the code generator generates its code, in that it's all abstractly kind of defined from method calls, or on a method call perspective, and in metadata, how things are represented in the backend. So, for example, we talk about the existence of a local table or parameters. We talk about the type characters on the Java side. We talk about getting the number of parameters, generating the switch to interpreter pre-prologue, generating the epilogue, methods for loading arguments from the stack or saving arguments on the stack, saving arguments in the local array. All those things are all the things that are I'll say publicly facing to compilation thread are incredibly generic in that they say things like setting the peak stack size or returning the peak stack size, getting things like or generating the pre-prologue, generating the prologue, the cold area, the body, those things in the right order. Those kinds of things would then be implemented in a architecture-specific code generator. So the things I'm listing off right now are part of a class called code generator. Just get the full name of it with its namespace, called code generator, in a file called AMD64 CodeGen, and it all takes place in a namespace called MJIT. I know on the TR side that's done, there's something with namespaces, and I think it's called static, it's static something, static polymorphism. I'm blanking on the name right now. But in TR, there's a generic code generator, and then there will be specific ones for each architecture. And then at compile time, the correct one's chosen based on the architecture you're targeting. So while we haven't set that up explicitly right now, those files, AMD64 CodeGen, AMD64 CodeGen GC, AMD64 linkage, the bytecodes assembly file and the linkage assembly file, all of those are under folders called X and AMD64, modeled after the way it's structured in TR. So my idea for how this would be done in those other architectures would be that under the MicroJIT folder, anything that is reusable across all of the architectures would go under the MicroJIT folder more or less directly. Then there's an assembly folder there for things that are architecture neutral, that are in assembly, like macros for defining the start and end of a template. And then everything else ends up going under architecture-specific folders. So if we decide to support the 32-bit x86 option, then the 32-bit folder will go in under the X folder as a subfolder. When we support Power, there will be a P folder just like, and a Z folder, all those things, just like there is for TR.
Okay. Right, but there's still a fair bit of work there then to enable each of the additional platforms, right?
There's a fair bit of work in enabling the other platforms. I'm imagining something because for those who aren't aware, this is a research project with the University of New Brunswick, and we're imagining that down the line we might get students to start working on for master's or PhD projects, porting to other architectures for other purposes. One of our current things that we're targeting, as we said early on in the meeting, is resource-constrained environments. That's a great reason, once we've kind of gone down the x86 path of that, a great extension of that work could be testing it in resource-constrained environments that run ARM, 32 and 64-bit ARM. And then similarly, when someone takes the work that's on, someone could take the work on accelerating startup times and attempt that in a Z or a Power environment.
Okay.
So
Okay.
I do have another question along that line, and apologies, I'm going to have to drop in a minute, so maybe something we want to save for another discussion, or you can continue without me. But you mentioned that this is a research project. What kind of time frame are you making a commitment to this code for? Right? Is this something that, as part of your research, your team intends to work through not only handing the code off, but then helping to stabilize it and effectively productize it? Or is this a sort of a one-time contribution?
So there's, I guess that's a bit of a multifaceted answer. So because we're a research group with the university, we get a lot of funding from funding agencies, many of whom care about things like our open source contributions. And so those things go in our funding reports. So part of our story for getting funding does involve how we're contributing to the open source community and how that's being used in our local community. So continued work on stabilizing this thing would indeed be something that, while some people might be doing it as a passion project after they finish their studies, would mostly be done by students as part of their research work, because that's part of how we get money from our funding agencies, is having those open source contributions. So it would be a thing that students would be doing on a go-forward basis. And the other side of that was is this a one and done kind of thing? Is that so I myself, as well as the students who are currently working on it, are all right now doing due to graduate or are currently working on things that are in the realm of like 2 to 3 years. So I believe I'm slated, if I continue working at the progress I'm going, to graduate sometime around December of 2021. So I'm 100% committed to this code base at the very least until December of 2021, and may continue working on it as a side project myself personally. But the research group as a whole will continue to work on this for a long time to come. There's a large number of research opportunities, things like right now, MicroJIT is a completely non-optimizing templated compiler, but are there templatable optimizations, like peephole optimizations, and what's the cost at compile time of those? Does that actually slow our startup time by trying to optimize? Those kinds of questions are things that people will want to research and will want to test across architectures. So there's a lot of research to do in the field. So there's the assumption then is that we will have a lot of people that will be able to work on it over time.
Okay, that's a great answer, because it sounds like there's a a long-term ongoing commitment to this code base, which I think is a great thing to be hearing.
Thank you.
Yeah, I think for the project overall, that's the kind of thing that we're looking for somebody who's looking to contribute something so significant into the code base, right? So that we don't have it sitting there going rotten over a longer period of time, which might make the project need to think about keeping it. And if it's not being maintained, then it could become a liability.
Yeah, and that makes sense because there's, like, especially on a large project with a large number of people working on it, there are pieces of the code base that you may never see in 20 years of working on the project. So if no one's working specifically in the MicroJIT area, then it could become rotten pretty quickly. However, I don't think that we're going to have a problem with that on our side, at least at the university, because this project, the initial version of this project that was worked on, started back in 2016, and I believe not 2016, earlier than 2016. I believe that was when the first student graduated, was in 2016. Aaron's on call. He could probably correct me on when Federico started. But this has been an ongoing project with the University of New Brunswick for quite a while. My understanding is that it is intended to continue to be so.
I'm sorry, I have to drop now. So
Thank you for coming.
For the conversation.
Yep. So with that, we do have about 15 minutes left in the current call. So since we have had some great discussions on here, and I think that we're going to need to have some more discussions and collaboration between the project and you folks at UNB to get this to the point where it's going to be integrated into the code base. I did make a note on the agenda document just of some of the high-level integration areas where I think we may need to look at some greater levels of synergy with the existing infrastructure before we can integrate the code, just so that there is a way for it to be tested and a way for it to function without, significant impact onto the functioning of the core project, right? So the notes I made there were for compilation control, the linkage and the calling convention, because duplicating that stuff is not ideal, and there are changes coming in the not too distant future to support the Project Valhalla value types, which will impact on the linkage. So avoiding duplication of that would be great. And I think making sure that the structure is there for the multi-platform support. We haven't had a discussion about testing, which I think is probably a separate discussion that we need to have, but how it's going to be tested and what tests are going to be contributed with it to make sure that it doesn't rot. I think just from what I've heard, and I hope it's in line with what other people are saying, I mean, there's certainly some very cool technology here. I think it addresses a need in the project, so I certainly think that it's of interest. And I think we just need to work on some of these design points to get the right compromise ready for it to be merged. Especially things like the register conventions and things, so that things like stack walking and the debug tools and everything will just work with it rather than being hugely surprised by how things are laid out. So I think we need to have some discussions around that. So I guess the last thing that we should look at is how we're going to move forward from this point. I certainly think we probably should have another call. There were certainly some discussion points, I think, that weren't fully addressed. So I'd be happy to set another one of those up in 2 weeks if that works for people on the call. I'll pause there for suggestions of other ideas of how to proceed.
I'm in favor of a bi-weekly call. Weekly is nicer for me, but I also know that you guys are incredibly busy, and adding a almost 1 hour meeting to your Fridays is probably far from ideal. bi-weekly is definitely sufficient for having these kind of discussions, though. And a weekly, we'd probably burn through a lot of this until we got down to code work, and then these became almost rote. So I think bi-weekly is pretty good.
Okay, great. So I will take an action item to schedule a meeting for so it would make it the 3rd of July. Would be 2 weeks. So I'll tentatively say 3rd of July at the same time to have another discussion. I guess what other items should we, or what other concrete items should we have? I guess, do we need to connect you guys with more experts on some of the points of integration to have some more detailed discussion, or do we need some people to do code review, or what are the other things that we can do to help get this moved forward from your perspective? Scott, I guess, would be a from those areas that we talked about.
So we have had at least one, more than one code review from Keith Campbell on the PR to OpenJ9, as well as the PR to OpenJ9, OpenJDK, JDK8. Right now, I guess the thing that I'm missing so far is, I guess, probably people who will work more tightly with integration in terms of where things like linkage, the stack walker, stuff like that that's very generic or is defined generically, and then the code is written generically, but it calls down to something architecture specific. Where those things exist in TR and how I can interface with them correctly, because for the most part, the way I've been getting through that is Slack questions, trial and error, and looking at the raw plate output of a code generator. So anything that anyone can do to look at where I integrate with TR, or I should say where the team integrates with TR, where MicroJIT is doing its own thing, but you can see how we could use something from TR either to remove code duplication or allow us to support even more things would be amazing help.
Okay, so maybe
and all code reviews are great as well.
Okay, so maybe we'll schedule the next one of these meetings to continue some of the discussions. I think that maybe what I'll do is I'll summarize into the pull request and a comment just a couple of these areas for integration, and I can some of the code owners that, or people that are significant contributors to those areas, just so that they're aware of the desire for greater integration there, just so you have GitHub handles for them. And I guess some of that discussion can probably take place on the PR. If you think that there's going to be enough traffic, we could also look to set up a Slack channel on the OpenJ9 space to discuss MicroJIT. If you think there's going to be enough back and forth, then we could try and just contain that into a Slack channel and have a more interactive discussion on the lower level stuff there, if that would be helpful.
I imagine that would be pretty good.
Okay.
I would probably clarify that when we're talking about things in the open, I guess that channel should be on the Eclipse OpenJ9 Slack, and not
yeah. So it would be a OpenJ9 community Slack channel for the discussion of these integrations as part of the project's work. Right.
Okay.
So it would be separate from any IBM specific things that we may have elsewhere. This is. Here we're talking as the project, and so the project will create a channel where there can be open discussion from anybody who's interested about these particular things. So I'll take action to discuss with Dan to see if we can get one of those set up so that we can have a place to talk about this. I'll set up a follow-up discussion. I'll put these areas on the PR, and I guess we should just try and continue the discussions on the PR for the specifics of integration in some of these areas so that we can get that hashed out and ready for the PR, since I think we just need to get the rough areas of some of these things defined and roughed into that first PR before we accept it.
Perfect. That would be awesome. Thank you very much, Andrew.
Okay. All right. Is there any other things that people would like to raise at this point? Any other concerns? Any other points of integration that, while we may not have time to discuss, feel should be called out in the issue, or just any other business in general? I'll pause there and allow people to comment. No. Nope. Stunned silence.
It's a perfect call.
Okay. All right. So if that's the case, I think since we're nearly out of time, there's not really much point in continuing any discussions, just because we're just going to run out of time for everybody to discuss anything specific. So perhaps what we'll do is look to wrap the call up there. I'll do the comment on the PR and let Dan know about a desire to create a Slack channel, and we'll set the next meeting up for the 3rd of July, where we can continue, hopefully with some more specific agenda points that come out of the discussions on the PR and the Slack channel. I'll try and publish that agenda document early so that people can use it as a working document to populate ahead of the next call, where hopefully we'll be able to get into some more of the specifics and things that specifically need to be done before the project is in a position to accept the PR. All right. Okay. If there's no other business, then I'll take this opportunity to stop the recording, which we'll post to the OpenJ9 community YouTube channel for anybody who wants to reference it, or if you wish to point any colleagues at it. And we'll reconvene in 2 weeks. So thank you everyone for your participation. I hope we can see you again in 2 weeks, where we'll continue looking to see how we can get this technology integrated into OpenJ9. Thanks.
Thank you very much, Andrew.
Thanks, Andrew.
Thanks. Bye-bye.
Bye.